Hello everyone, welcome to my channel. Today we will discuss Leetcode question 221, which is maximal square. So let's read the question. Given an m cross n binary matrix filled with zeros and ones, find the largest square containing only ones and return the area. And so you will be given a m cross n matrix which will contain 0 and ones, and you need to find the largest square containing ones. So let's see the example discuss. Yeah. So here you can see example one. It is 1, 0, 1, 1. All the means the matrix is containing one and zeros, and the maximal square you can see is this and this. And you need to return its area. Area means for this square, area will be 4, and for this area will be 4. So output for this will be 4. So yeah, you can see that output is 4. So let's see the another example. Another example is the 0, 1, 1, 0. So one of the possible square containing one is this one, and another is this one. So area of both of them is 1. So answer for this will be 1. So let's discuss the approach. So this question can be done using the recursion. So how we can do it using recursion? Okay, so what we will do, if I'm standing at any index, means any cell in a matrix, if I know that what my right cell means what my right cell is able to make a square, means uh, what is the area of the square that my right cell is able to make, and what my bottom cell is able to make, and what my diagonal cell is able to make. If I know these three details, then I can calculate the how many area square my current cell will make. Okay, so how we will means how we will calculate area for this. So for this we can see that it is 0. So it will not form any square. Okay, and this is also 0. So this will also not form any square. This is 1. Okay, so this cell will able to make a square which will be containing 1 only, which is of area 1. So we get to know that this cell is able to make 0 square, this cell is able to make 0, and this cell is able to make 1. So what I will do, I will take the minimum of all the three. Means we will do a recursion call to all the right cell, bottom cell, and diagonal cell. And whatever we will get, we will take minimum of them. Why we will take minimum? Let's say this another cell. Let's say this cell. Okay. So if I am standing at this cell, so I will ask to my right cell, "Ki uh, what area square are you able to make?" So this is able to make this square, right? This is the largest area that this cell is able to make. And again, it will ask the bottom cell, what area are you able to make? So this is able to make only one area square. Then it will ask for the diagonal. What square are you able to form? So this is also able to form one, one square area. So we saw that from my right cell, I got this is able to make a square with 4 cells. Okay, so 4 cells or 2 cross 2. Okay, so Let's see. Uh, let's see the number. Return the number of sides from this. So it will return 2. It will return 1. It will return 1. Means it is able to form a square of side length 1 and it is able to make a square of side length 2. So I will take the minimum of all these three. So minimum is 1. Uh, Minimum is 1. So it will return 1. It, sorry, I will take minimum of all these three. So it will get 1 out of these three calls, recursion calls. And it is also 1. So it will return, it will uh, add a 1 to this uh, because the below or any means any of the additional cell is making 1 and this is also 1. So it is able to make a square of 2. So whatever recursion call will be coming to this, it will return 2. Okay. And we will have a we will keep a resultant variable that will store the maximized result. So now let's tell you why we are taking minimum out of this three. So let's see. Let me take this. Yeah. So you can see this. This cell is able to make a square of side length 2, which is this. Okay. And this cell is able to make square of side length 1, which is this. And this cell is able to make of side length 1, square of side length 1. So if I will make a square for this, so I will consider this square, which is uh, which will which will overlap in all the three. Suppose if suppose suppose this cell is also 1 and this is also 1, then this cell will be able to make a square of side 2 length and this will be the square. So we can see that uh, this is having side length 2, but I can't take this 2 because if I will take this 2, it will be a rectangle. So that's why we need to take minimum because if we will take maximum, suppose this is also having a square of side 2, this is also having a square of side 2, and we will take 2, then this should be the square. This should be the square, but this is 0. So that's why we are taking minimum. So because this cell is able to make a square of this only, so I can form a square with these cells only. If suppose this is also 1, if this is also 1, then all these three recursion call to those three cells will be returning 2 and minimum will be 2 only. So this cell, this cell will able to make a square of side 3, which will be this square. So this is our logic and intuition. So let's see the code. Yeah. So I have made a recursive function where I'm taking the matrix and the index that I'm processing, and I am using a DP. I have taken DP because if we will use only recursion, it will give TLE. So that's why we are using DP. So I have added the base condition that if matrix size is if x goes beyond the matrix size or y goes beyond the row size or the matrix is zero, then in that case it will return zero. And after that, I have checked in my DP matrix whether I have already calculated the result for that um, coordinates. If I have already calculated, then I'm simply returning it. And after that, I have made a recursive call to right cell, then down cell, and then diagonal cell. And yeah, after that, I'm taking minimum of all these, right, down, and diagonal, and adding one to it and assigning it to the DB vector. So let's see the main function. Yeah. In my main functions, I have created the DP matrix and I'm running a double for loops, simply checking whether that matrix means uh, coordinate of that matrix is one. If it is one, then I am maximizing my result. Means whatever I'm getting result from that cell, I'm maximizing that because I need to return the square with the maximum area. Okay. So this rest variable is storing the length of the side, and in the end, I'm returning side into side, which will be the area of the square. So let's run this code. Yeah, it's passing all the given test cases. Let's submit it. Yeah, it's passing all the given test cases. So time complexity for uh, this will be yes. So the time complexity for this will be O of n cross m. As we are running a for loop and inside that I'm calculating our result. Yes. So thank you for watching. Do like, share, and subscribe.